Hello students, welcome to the class. So today we will do the mock test analysis of the mock test number 7. So we will be having 40 minutes. Meanwhile, I will suggest you to attempt this test along with me. We have to solve 20 questions in this given time. So let's start. First question, which of the following reactions represents oxidation according to the classical definition? Now what is the classical definition? It says that addition of any electronegative element represents oxidation. Okay. Now from that point of view, we can easily say that the second option is correct, which is addition of oxygen to methane. Now what about other options? If we explore the first one, it's very clear that oxygen is removed from mercury. Hopefully, according to the classical definition, it is reduction. Similarly, if I look upon the third one, again there is a removal of electronegative element, which is chlorine. So again it's a reduction. So the correct option is option number second. Moving on to the next question. The next question is, for the following reaction MnO4 minus reacting with I minus to give us MnO2 and I2, you have to say that what is the coefficient of H2O. How you will do it? For that you need to balance the reaction. So I will be using the half reaction method to balance it. If I write this whole reaction, so MnO4 minus with I minus giving us MnO2 plus I2. To know the oxidation and reduction, we have to assign the oxidation number. So for manganese it will be plus 7, for oxygen minus 2, iodine minus 1. Here it will be plus 4 for manganese and minus 2 for oxygen and 0 for iodine. So there is no anomaly in it, you can just assign it simply. If you look for the oxidation and reduction reactions, so this is the reduction half reaction where your manganese is going from plus 7 to plus 4. So this is your reduction half reaction. Okay, so MnO4 minus going on to MnO2. Let me write the oxidation half reaction as well. So here it will be oxidation half reaction. Obviously, from I minus to I2 is a sample of oxidation because the oxidation number is increasing from minus 1 to 0. So if I write the oxidation half reaction, it will be I minus going to I2. Now what is the first step after separating the half reactions? It is to balance all other atoms except oxygen and hydrogen. If you look upon the reduction half reaction, you don't have to do anything because manganese is already balanced, and I told you you don't need to balance oxygen and hydrogen right now. What about oxidation half reaction? Yes, you need a change because two iodines are present on the right hand side, so you have to multiply the left iodide with 2. So from the first step, what do we get? The first reduction half reaction is remained as it is, MnO2. Okay, and the oxidation half reaction is changed by multiplying 2 as a coefficient with I minus. What is the next step? It is to balance oxygen and hydrogen. How we'll do it? So if you look upon the reduction half reaction, there are 4 oxygens, whereas on the right hand side 2 oxygens are present. So to balance oxygen, we need water molecules. Remember, to balance oxygen we use water molecules as a source of oxygen. So we need 2 more oxygens. So on adding 2 H2O, you will get 2 oxygens. Now what about the right hand side, the oxidation half reaction? It is not having oxygen neither hydrogen. So we don't need to do anything to it. It will be remaining same. Moving on next. Now we need to balance the hydrogen. How do we balance it? By adding H plus. We know that on the right hand side we have 4 hydrogens, on left hand side we have no hydrogen. So we will add 4H plus. Okay, on the left hand side. So this is your reaction now. Moving on to the next. What is the next step? It is to balance charge. How will balance the charge? So if you look on the left hand side, we have a 3 positive charge. Why? Because 1 negative charge is coming from MnO4 minus and 4 positive charge from H plus. So 4 minus 1, that means 3 positive charge. Now to balance the charge, we have to add 3 electrons onto the left hand side. MnO2 and H2H2O. So this will be. Now on the right hand side, charge needs to be balanced, because on the left hand side we have 2 negative charge, on the right hand side we have no charge. So here 2 electrons are added. What is the next step? The next step is to multiply in such a way the whole equation that the electron count becomes equal. So 3 electrons are there in the reduction half reaction, 2 electrons are there in the oxidation half reaction. If we multiply the reduction half reaction by 3 and the oxidation half reaction by 3, by 2, by 3, yeah, and the reduction half reaction by 2, not by 3, because we are making both of them equals to 6. Now what will be the result of it? There will be 2 MnO4 minus plus 8 H plus 6 electrons, then MnO2 with a 2s coefficient and 4H2O. This will be the case. Whereas the oxidation half reaction will be converted onto 6I minus, then 3I2, then 2 electron. But the reaction is occurring in a basic medium. So before adding it, we need to make it basic. In the oxidation half reaction, we don't need to do anything because no presence of H plus and OH minus seen in it. Whereas in the reduction half reaction, 8 H plus are present. So you need to add 8 OH minus on both sides, so that the overall reaction occurs in a basic medium. So that will result in 8 H2O, because 8 H plus and 8 OH minus will result in 8 H2O. Okay. Similarly, you will add 8 OH minus on the right hand side as well. So this will give you 4 H2O plus 8 OH minus. Now 8 H2O minus 4 H2O. So we will bring this 4 H2O on the left hand side. So this will give you your final reduction half reaction. 2 MnO4 minus plus 8 H2O plus 6 electron. Okay, so this will be subtracted. 8 and 4 will be subtracted and it will give you 4 H2O. So 4 H2O, 6 electrons gives you 2 MnO2 plus 8 OH minus. Now this is your final equation for reduction half reaction, and this is your final equation for oxidation half reaction. You will add both of these reactions. What you will get? So let me write it here on the top. So you have to simply add it. Remember, while adding both of them, the number of electrons is equal but are present on the opposite side. Like in the oxidation half reaction, it is present on the right hand side, and the reduction half reaction, it will present on the left hand side. So on adding it, the electrons will get cancelled out. So this and this will get cancelled out. Okay, so this 3 multiplied by 2, so it will be 6 here. Okay, so this will be converted into 6. So this and this will get cancelled out. Finally, what you will get? 2MnO4 minus plus 4H2O. Then 6I minus, and upon reaction it will give you 2MnO2 plus 3I2 plus 8OH minus. So this is your balanced chemical equation. You are being asked to write the coefficient of H2O. So it will be 4. So the correct answer will be option number 2nd. Moving on to the next question. Again, you need to balance this reaction and find that what is the number of OH minus ions in the balanced equation. Again, we will write the principal equation here. So MnO4 minus plus Br minus is giving us MnO2 and BrO3 minus. Assign the oxidation number. So here it will be plus 7, minus 2 for oxygen, minus 1, plus 4 for manganese, minus 2 for oxygen, 3 to just 6, minus 1 plus 5. You can easily say that this MnO4 minus is reduced to MnO2 and Br minus is reduced to BrO3 because the oxidation number is increasing from minus 1 to minus plus 5 in bromine, and the oxidation number is decreasing from plus 7 to plus 4 in manganese. So let us write each of these half reactions. So first of all, I will write the reduction half reaction. So I am writing it as reduction half reaction, RKN. So this is MnO4 minus giving us MnO2. Here Br minus is giving us BrO3 minus. Now there is a very tricky part in it. If you know that what is the final equation, in this you know the final equation, that before multiplying it to equalize the electron, you know the final equation. What will be the final equation for MnO4 minus to MnO2? Because balancing half reactions is an independent thing, right? Till the point you balance the electron. Okay, so on balancing it, you need to compare it with the corresponding oxidation half reaction. But before that, all steps will be same. So you will get the same thing, okay? So oxidation half reaction. Okay, so this is your oxidation half reaction. Now, if you remember, then what was the balanced equation? So let me write it for you. You can just try this out. Only one thing you don't need to do is to make the electrons equal. Rest of the steps will be same. Okay. So if I just go back and check it out, so that will be MnO4 minus plus 4H2O was there. Okay. And this was giving us. So let me do it again. So that will be good. Okay. So it may confuse you in a way. So we will do it again. So MnO4 minus, then manganese is already balanced. So we need to balance the oxygen. So MnO4 minus MnO2 plus 2H2O. Right? Then next thing is to balance hydrogen. So MnO4 minus plus 4H plus, giving us MnO2 plus 4H2O. Okay. What about the next thing? We need to balance charge. So we need to add 3 electrons here. MnO4 minus plus 4H plus 3 electrons. MnO2 plus 4H2. Again, this reaction is under basic condition. So we will add 4 OH minus on both sides. Okay, here it will be 2. So MnO4 minus plus 4H2O plus 3 electrons, giving us MnO2 plus how many OH minus? 4 OH minus. Okay, and 2H2O. Again you will subtract 4 from 2 and this will give you your equation for MnO4 minus, which is MnO4 minus 2H2O, giving us plus 3 electrons, plus 3 electrons, giving us MnO2 plus 4 OH minus. Okay, what about this reaction? So again here bromine is already balanced, so we need to balance oxygen. There are 3 less oxygens on the left hand side, so I will add 3H2O on the left hand side. Our next thing is to balance hydrogen. For that you will add 6H plus on the right hand side, because 6 hydrogens are present on the left hand side. So 3H2O, BrO3 minus plus 6H plus. Right, so this is correct. Okay, what is the next thing? We need to now balance the charge, but before that we have to make this system basic. How we will do it? By adding 6 OH minus on both sides. So Br minus 3H2O plus 6 OH minus. Okay, there is one more thing. You can add this OH minus after adding both the equations, so that can also be a part, or you can do it before. So easier would be to add it after, right? So I'm doing it before, but 6H2O. Okay, now this will be converted onto, so 6 minus 3, 3H2O on the right hand side. So BrO3 minus 3H2 on the right hand side. Okay, now what is the charge balance? On the left hand side we have 7 negative charge, minus 7 charge is present. On the right hand side we have 1 negative charge, so we have to add 6 electrons here. So 6 OH minus BrO3 minus 3H2O plus 6 electrons. So 6 plus 1, 7 charge, 7 negative charge. On the left hand side also we have 7 negative charge. Now we need to equalize this number of electrons. What we will do? We will multiply the obtained reduction half reaction with 2. So that will give you 2 MnO4 minus 4H2O, 6 electrons, giving us 2 MnO2 plus 8 OH minus. Now you will add both of these equations. So adding both these equations, what it will give? It will give you, so I am writing all of the things apart from your H2O molecules and electrons. So electrons will get cancelled out. So this and this will get cancelled out. What about OH minus? So there are 8 OH minus on the right hand side for the reduction half reaction. Whereas in the case of oxidation half reaction, there are 6 OH minus. When you will add, so 8 minus 6, so 2 will be present on the right hand side. Okay, so 2 OH minus on the right hand side. Then we have 2 MnO2. Okay, what are the other things? So we have BrO3 minus, and we have 3H2O. So 4 minus 3, so that will leave you with 1 H2O. It was asked to calculate the number of OH minus. You can see it very clearly, it is 2. So the correct answer will be second one. Moving on to the next question. Which step is incorrect in the oxidation number method for balancing of the redox reactions? So assigning oxidation number to all atoms. So this is true. It's the first step in both the methods, I would say. Next is balancing hydrogen and oxygen first. Sorry, other atoms other than hydrogen and oxygen. Okay, so this is also correct. You first balance other atoms except hydrogen and oxygen. Then adding H2O to balance oxygen atom. So this is also correct. The last one is incorrect. Equalizing electron transfer without considering the charge balance. So this is incorrect one. Moving on to the next question. You have to balance this given equation with the help of half reaction method and see that what is the electron transferred. You have to basically count the number of electrons that you will get before adding. So before adding, the electron count that you are getting is the electron transferred. So I am assigning the oxidation number here on only. So this is +2 for iron. 7 2 is 14. 14 minus 2, 12. 12 by 2, 6. So +6 oxidation state. Fe3 plus will be in the +3 and Cr3 plus will be in the +3. You can see it very clearly that iron is getting oxidized. So if I write the oxidation half reaction, it will be Fe2 plus going on to Fe3 plus. So this is your, so I am writing the oxidation half reaction as OHF. What is the reduction half reaction? So this is Cr2O7 2 minus going on to Cr3 plus. What was the oxidation state? +6 here, -2 here, okay, +2 here, +3 here, and +3 here. What is the next step? Now we need to balance all other atoms except oxygen and hydrogen. So in iron we don't have any oxygen and hydrogen, and iron is already balanced. What about chromium? So here we multiply with 2, chromium 3 plus with 2. So Cr2O4 7 2 minus 2 Cr3 plus. What is the next step? Now we balance oxygen and hydrogen. See, we don't have any oxygen and hydrogen in the oxidation half reaction. We will only do it in the reduction half reaction. For that, we will add 7 H2Os. Okay. Next thing is to balance hydrogen. For that, we will add 14H plus, because 14 hydrogens are on the right hand side, and no hydrogens are present on the left hand side in the reduction half reaction. So 14H plus. Then 2Cr3 plus 7H2O. The last task is to balance charge. Here, if you see in the right hand, in the oxidation half reaction, then +2 charge is there on the left hand side and +3 on the right hand side. So I will add 1 electron on the right hand side to make the charge equal. Now you don't need to add what? Your OH minus, because the reaction is occurring in the acidic medium. Okay. What about this? So 2 negative charge, 14 minus 2, that means 12 positive charge is present. On the right hand side we have 6 positive charge. So to make the charge equal, we will add 6 electrons here. Where? On the left hand side. 6 electrons. What is the next step? It is to make the electrons equal in both oxidation half reaction and reduction half reaction. So for that, you will multiply the oxidation half reaction by 6. So 6 electrons, 6 Fe3 plus 6 Fe2 plus. Do we need to continue further? No, because now we got the electron transfer count, which is 6 electrons. So the correct answer will be 6. Moving on further. So this question is directly from the NCERT in-text question. We have already done it. So I will suggest you to do again along with me. But I am leaving this question for now. Okay. Next question. In the reaction 2HgCl2, NCl2, Hg2Cl2, SnCl4, which species is getting oxidized? So it's very easy. First of all, I will give -1 oxidation state to each chlorine because they are present in the combined state, and usually with the metals we get a -1 oxidation state. Now to make the compound neutral, you have to give +2 oxidation for mercury of HgCl2 because -2 is coming from chlorine. Similarly, this 10 will also get +2, but here the mercury will get +1 because 2 mercuries are there, whereas this Sn will get +4. Now you can easily see that the oxidation state of tin is increasing from +2 to +4. So this is getting oxidized. So SnCl2 is the correct answer. Next question. Okay, so let me just clear it for you. Yeah. So this question says that which of the following reaction involves oxidation of sodium? So this question is very easy in a way because all these 3 reactions have no sodium atom in it. So neither sodium is getting oxidized nor reduced in these 3 reactions. So all these 3 reactions are eliminated in a way. You can just check this first option and see and confirm that this answer is correct or not. In a way, the first is correct and you know it for sure, but we shall check it once. Okay. So 11th option was. So what will the correct answer? Of course, your first one. So let's verify it. Sodium is in 0 oxidation state, chlorine is in 0 oxidation state. Here sodium will get +1 and the chlorine will get -1. Yes. So the oxidation state is increasing from 0 to +1. So the correct answer will be obviously option number first. Next is, which species cannot act as an oxidizing agent? If it should act as an oxidizing agent in one case only, if it will get reduced. For that, what is the criteria for oxidation number? So if it is getting reduced, that means its oxidation number has to go to a lower state. But if an element is already present in its lowest state, then it cannot go down further. If you look upon the oxidation state for each of this, then here the chlorine is having 4 to the 8 plus 7. Yes, so it can go to a lower state because it is the highest oxidation state for chlorine. Similarly, this manganese is also in the highest oxidation state. Again, it can go to a lower state easily. You know it, MnO2 is just that state. Then in this 7 to the 14 minus 2, 7 plus 6 oxidation state. So this is also in a higher oxidation state. But if you look upon iodine, it is already in its lowest oxidation state, which is -1. If it was in 0 oxidation state, then it can go to a lower oxidation state, -1. In that case, it can act as an oxidizing agent. But in this case, iodine can never act as an oxidizing agent because it is already in its lowest oxidation state possible. Next question, a easy one. You have to decide what is the oxidation state for Mn. So let us do it. If I tell that suppose the oxidation state of manganese is X, you know it very well that potassium can have a maximum oxidation state of +1. Manganese will be considered as X and oxygen will be taken as -2. So 4 into -2. Overall the compound is neutral, so the overall charge will be taken as 0. If you just calculate it, so 4 to the 8, 8 minus 1, 7. So +7 is the answer. Next question. Which of the following species is getting disproportionate? So let us first put the oxidation number. Okay, what is disproportionate reaction? Where your same element is going to 2 different oxidation states. If you check it for the first reaction, then here this H2O2, what will be the oxidation state of oxygen? You know it very well that hydrogen can have a maximum oxidation state of +1 due to availability of only 1 electron. Therefore, if you need to keep the compound neutral, you can only assign a minimum oxidation state of -1 to oxygen. Okay. Here, what will be the oxidation state of oxygen in the water? Of course, it is -2, and here it is 0. You can see it very clearly that your oxygen, which is in the -1 oxidation state, it is going to a higher oxidation state 0, which is oxidation, and a lower oxidation also, which is -2. So basically the same species is getting oxidized as well as reduced. Therefore, this is a classical example of disproportionation reaction. Next question. What is the oxidation number of sulfur in SO4 6 2-? Okay, so this is a tricky part, because the oxidation state that you will get, it is a hypothetical one, because you will get a fractional oxidation state. You can try this thing by yourself. Let us do it. Okay, so let us suppose that oxidation number of sulfur is X. So X into 4 plus oxidation number of oxygen will be -2 and overall charge is -2. If you just calculate it, you will get it as 2.5. So fractional oxidation state is of course not a regular one and not acceptable also, but still this is a rule and you have to assign the oxidation state. But if you just draw the actual structure, you will get different oxidation state for sulfur itself. Okay, moving on to the next question. What is the oxidation state of oxygen? You have to see that which one is having a +1 oxidation state. We have already done it for H2O2, it was -1. What about OF2? So 2 fluorines are there. Fluorine can have a minimum oxidation state of -1. So 2 fluorines, that means -2 due to fluorine. So +2 will be assigned to oxygen. Here 2 oxygens are here. So you have to assign +1 oxidation state to each oxygen to keep the compound what? Neutral. Therefore, the correct answer is third one. Next question. In the reaction 2Na plus H2 giving us 2NaH, which statement is correct? I think we have seen this question. The correct answer was the sodium is getting reduced, oxidized, okay? And if it is getting oxidized, then it means it will act as a reducing agent. So this is obviously not correct, and this is also not correct. What about hydrogen? Yes, this will act as an oxidizing agent, because if sodium is getting reduced, oxidized, that means hydrogen is getting reduced. And if it is getting reduced, then it is acting as an oxidizing agent. So correct option will be the last one. Next question. Which observation confirms the formation of Zn2 plus here? White precipitate with H2S in alkaline medium. You have seen this thing. To observe this change, we pass on H2S onto the solution to form the white precipitate. In case of absence of the Zn2 plus, we have a blue color solution due to Cu2 plus, but as soon as you do this reaction, Zn2 plus is formed, and to confirm this, we pass H2S gas through the solution, keeping the medium as alkaline to get white precipitate. Last question. In the reaction, which species is acting as oxidizing agent? It's very easy. The species which is getting reduced is the species acting as oxidizing agent. You can see here that Cu2 plus is getting reduced. From Cu2 plus is going to Cu. That means you are removing 2 electron. Whereas, sorry, you are adding 2 electron. Whereas Zn is going from Zn to Zn2 plus. That means you are removing 2 electron. So Zn is what? Zn is undergoing oxidation, and it will act as a reducing agent. Whereas your Cu2 plus is undergoing reduction due to addition of 2 electron, and it will act as an oxidizing agent. So the correct answer will be Cu2 plus. So this is the last question. So thank you for joining the session. I hope you enjoyed it.